So we have the question, remove element. Given an integer array nums and integer value, remove all occurrences of val in nums in place. The order of the elements may be changed, then return the number of elements in nums which are not equal to val. First of all, when I start solving questions, I make a list of things that should be like the first step. I identify the input. So the input is array and a value, for example, number value, and output should be also number. Okay, number of elements not equal to given value. Actually, it should be integer. Consider the number of elements in nums which are not equal to value to be k. To get accepted, you need to do the following. Change the array nums such the first k elements of nums contain the elements which are not equal to value. The remaining elements of nums are not important, as well as the size of nums. Return k. Which means is like we can look at the examples. Start by looking at the examples. We have two cases right here. So what it says is that we need to remove every 3 we find inside this nums array. But while doing so, we should change it in place, which means we cannot create a new array or cannot change, like return a new array. We need to work with this nums array that's given to us. And they are asking us every time when we see the value, move it to the end. Or do something with it so that at the end of the question, like at the end, the output will be numbers array and everything else at the end. It cannot, it can be underscore or like it can be 2, 2, 3, and 3. We should give which numbers like are sorted or are not sorted, are filtered. For example, it means like first 2 numbers are filtered, we removed everything, and we counted numbers that are not equal to 3 are 2. So we have these 2, double 2 here. These are like, that's the number of items we are returning. And we can also have a look at the second example. And here, we are looking for 2. So we have 1, 2, 3 2's here in the array. We need to remove them from here and add it to the back, or make like underscores or anything at the back of the of these nums. And here on the output, we are giving 5, the count of numbers that are not equal to 2, which are like 0, 1, 3, 0, and 4. First, and we are assigning, like arranging those numbers in the first order so that the first 5 numbers are filtered and the rest can be anything. And also, one thing to note, it says that the 5 elements, like the first 5 elements, can be returned in any order. Another valid response would be 3, 4, 0, 0, and 1. And dot, dot, dot. And here there is like custom judge. How this is explaining how our example will be judged. So expected nums dot length. So the first k elements of the how they're judging is like they're getting our response array, splicing it, and then sorting it so that even if you give the answer in any order, it will match their answers. Like when sorted, this one is equal to this one if we sort both of them using the functions, sort functions. And it also says like it does not matter what you leave beyond returned k. So it can be underscore, it can be the number itself, or anything. There is, yeah, it does not matter. Okay, the first thing that comes to my mind, like I would suggest, is to give more. Once you like to validate that you understand the question, you can write your own custom input and outputs. For example, we can give an input of nums equal to, for example, empty list. What happens here? We have first of all, like, we can ask for constraints. What are the constraints? And they will say like the numbers length. There will always be, it can be empty or less or equal to 100. So if it's empty, your output will be what? And we have a value of 3, so output will be 0, because there are no values at all here. The next question would be, can value be 0 or nums I? Okay, every value in the numbers is less than 50 or something. Okay, and also one case would be with duplicates. Will we have duplicates? As you can see, we will have lots of duplicates in both like values matching the given value and the other values as well. So what can be other edge cases? We may have something like this: input nums equal to 3222, and our value will be 2, and at z, like, output should be 0, and nums should stay the same, I believe, at this case, because there are no numbers not matching 2. Okay, so, or even we may have cases where value does not appear at all. We cannot find it. Our answer should be 4 at this case. I believe we have written enough custom cases. Now, at this stage, I would write a simple explanation of what I would do. The first thing that comes to my mind would be going through the list, and every time I come across a value that I'm looking for, which in this case is 2, I will move it to the end of the array. Something like adding it, like removing it from here, adding it back. This can be one solution, and whenever I see 2, I remove it, I add it back. The problem is I should know when to stop, because when I come to this 2 and there will be like another 2 behind, and then I may not know, like I may keep removing, adding back, and it may result in an infinite loop. That's one case. That's why we can keep a iteration, like for example, we only iterate through the whole list, number of length of the list. We will take it in a for loop, so just when that ends, we stop iterating. Another thing, but you know what? Every time you take something from the middle of the array, it will reshuffle everything and move their indices by -1, which results is like even if I take 1, which 2 here, take it out, which may seem like a one action, but the array will rearrange and move everything after it by 1 index. Like I'm doing actually 1, 2, 3, 4, 5 actions plus 1 plus 5 actions when I'm moving it. So another way to remove an element from the middle of the array with like one step would be replacing it with the last value and removing. For example, I can replace this 2 with 2 and make array dot pop, for example. But in this case, it actually does not ask to remove anything. We don't have to remove anything. We don't have to change the length of the array. We can just replace this with values from behind, like from the end of the array. Let's take this. We have this list. We iterate through. We will have 2 pointers. We will have this one pointer coming from the beginning of the array, one pointer starting at the end of the array. And we check, let's say, left, and we have right pointer. Left and right here. Okay, firstly, our left pointer is pointing to 0, and the right pointer will point to the last element of the array, which is 2. Like not 2, which is actually 1, 2, 3, 6, 7. The index of the last element, 7, which are 0 and 2. While the left pointer is like if left pointer item is not equal to the number we are looking for, in this case, which is 2, we keep incrementing it. So 0, we check. No, it's not equal to 1. Equal to 2. So we move it by 1. We keep it. Let me keep this pointer right here so that they don't move. Yeah, 1. It's pointing to 1. Is 1 equal to 2? No, we shift it to the next value. Is 2 equal to 2? Yes. When it's equal to 2, now we wanna check our right pointer and move it to the left until it's not matching. The reverse condition. We check our right pointer at this. We stop our left pointer and we check our right pointer. Is 2 equal to 2? Yes. If yes, we need to move it to the left. No, it's not. So both of our conditions are met. At this point, we wanna just change the values the pointers are pointing to and keep doing the logic. We say this one will be 4, this one will be 2. And we come back to our first logic. We check 4 is not equal to 2. We move our left. 2 is equal to 2. Okay, then we need to go back to our right now. 2. It's not matching condition. We move it to the left. And now the conditions are matching. We again shuffle, swap the elements, and with our left pointer we come here and check. Is 3 equal to 2? No, it is not. We move again. Is 2 equal to 2? Yes, but we need to have one more condition, which says left and right should not be equal. Like we do this checking only when they are not equal. At this point, we see that there is no meaning to check it. We should quit. So I will say something like that. While left is less than right. Okay, while left is less than right, or should we include equal to, less or equal to? Okay. No, we should not. It should work fine with it because we are keeping our right always at 2. But one thing we can do is while we assign. Okay, for now let's just keep it simple and keep going this way. While left is less than right, something like that. We want to we also need another condition while left not equal to value, increment left. And when this is true, we check right is equal to value, decrement. So that makes it possible to move our left and right pointers, and when we come here, it means our left value is on the right spot and right value also. So here we say swap left and right, and we keep doing the same, swap left and right, and then we come back and start from here. These two are inside this while loop. At the end, also one thing to note, we need to return a number of values that are not equal to the value we're looking for. So here on the swap place, we can say we will have a count, initialize count variable, and right here we increment the count. And so that at the end, return nums.length minus count, because we are counting the numbers that match 2. Okay, so every time we find a 2, we... one more thing here, there's a problem with this solution. Instead, like, we don't have to have a count. But the problem I found is, like, we had 1, 2 at the behind. Like, we didn't swap it, it was always here, so our answer will return 2, which is like 1, 2, 3, 6, 8 minus 2, 6, but the right answer is 5. Instead, what we can do is actually, when we reach that part right here, we can return the index. Like, the index right here is 6. 0, 1, 2, 3, 4, 6, right? 6. We can say something like left minus 1. The number of items before it, resembling. Yep. And we don't even have to initialize a new variable for that. That should make sense. Okay, let's check it with other values. Check the same logic, basically. Let's say we had this empty array, and our right and left, both of them are 0 at this point, and we check is left less than right. It's false. Okay, and we return left minus 1. Interesting. At this stage we will return minus 1. That's not a good practice. Will it be problematic for this case as well? Let's check. What I can think is, like, we can maybe avoid it with if statement. If nums.length less equals to 0, return 0. We can just say this to avoid that problem. But what if we have this case and value is 3 and right will be right here? We check. Okay, we have 2. We move this left until we find matching value that's not 3. We found it. Oh, actually I wanted to make it 2. So we found it. 2 is equal to 2. And we want to move right while it's not equal. We move right till here, and both of them will be at 0, pointing 0. Okay, actually, I think I did something wrong just right here. Can we go back while calculating the index? Oops, not here, not here, not here. Right here. What is left right now? 1, 2, 0, 1, 2, 3, 4, 5. It's actually 5. We don't return it. -1, we return left. That makes sense right now, because if we just return left or right, both of them are pointing to the same index, we return actually the numbers, count of numbers before it. So it will even work for the case where we have an empty list, where right and left will be equal to 0, and we just return 0. And for this case as well, where we don't have, we wanted to move our left, but we check, like, we don't have to move the left because it's equal. We move right all the way to the beginning, and they become 0, and then we just return left or right. I believe that should solve our problem. Let's code it up. While coding, I just like to take this and turn it into a code. Let me show you how. I believe I can end my comment like this, and here I will just write everything in the code. So we have we initialize our pointers. Let left equal to 0, right equal to nums.length -1, which is the last index of the nums. Okay, we have both of them, and say while left is less than right, we want to check for both conditions. While left, it's actually, here we are not checking the index left, we want to find nums left, which will give us the value at the left pointer. Okay, while nums left is not equal to the value we're looking for, just nums, just increment the left. And very similar case for right. After this one is done, we want to check this time is equal to, and we want to decrement, like just like this. And now we want to swap left and right here. For swapping, we need a temporary variable to store the value. For example, nums left, let's store it, and we say nums right should be temporary value that we stored. Just a second. Should actually nums right. Oh, we actually do not need that value, because we know that the value we are storing is the given here, right here. So no need for it. We just say we want to move our left pointer. On the left pointer, we should have the value that's currently on the right pointer. And for nums right, we don't actually care, but we want to put val, because so it will match our like we are for these conditions it will match, so we will put value which is 2, which can be 3 given on the case. Okay, we swapped, and then we go on, we decrement, we increment, and right here we can actually say left plus plus and right minus minus. So that we can skip one extra action. And right here, let's come and just return left. That should give us the solution. And what I also do after coding is yes, what I do after coding is I check. For example, I go through dry run with the code. That's why we got a question, like problem right now. Actually, before running anything, you can take your old examples that you have here